Okay, so this is Test Yourself 17. This is question 1. Okay, using pi equals 3.14, find the volume of the following cylinder. Volume of a cylinder is basically pi r squared h, which ends up to be 3.14 for pi, 30 squared for radius, and 40 for h. Put that into your calculator. You're going to get 3.14 multiplied by 30 squared multiplied by 40 square, 40 plus 40, and what you get is 113,040 13040 meters cubed. Find the curved surface area. So the curved surface area of a cylinder, or the curved surface area of a cylinder, equals 2 pi r h, which is 2 multiplied by 3.14 multiplied by 30 multiplied by 40. So basically the same thing again, except this time there's no squared, and this time there's a 2 in front of the 3.14. And then what we get for this is 7,536 meters squared. Okay, so that's question 1A answered. Now we're on 1B. 1B, the cylinder and the cone above have equal volumes. Find the volume of the cylinder in terms of pi. Well, the volume of this cylinder is, once again, volume of the cylinder is pi r squared h. It is going to be pi times 6 squared times 20. And then it's going to be 6 squared is 36. So, or you just put it on the calculator. Pi times 6 squared times 20 equals 720 pi. And then calculate h, the variable height of the cone. Well, we're told that they have equal volumes. So the volume of the cone is equal to a third pi r squared h, which is a third pi times 12 squared h. Now 12 squared here, if I put in a third, I'm just going to ignore the h for the time being. So you can see the h, I'm just going to ignore that. It's going to be shift pi, it's going to be 12 squared, and it's going to be 48 pi h. Now they have equal volumes, which means that 48 pi h equals 720 pi. So 48 pi h equals 720 pi. Pi is cancelled. And then 720 divided by 48. So 720 divided by 48. What we get there is 15. The height is 15 centimeters. Okay, so that's question 1 done. Now on to question 2. Soup is contained in a cylindrical saucepan which has an internal radius of 12. The depth of the soup is 18 centimeters. Calculate in terms of pi the volume of the soup in the saucepan. Well, the volume of the soup is occupying a cylinder. Okay, and then you have the level of the soup. So what we have here is our diagram. And then we can say that the soup, let's call it tomato soup, is here. Okay, and then what we have is the depth of the soup is 18. The radius is 12, so we need to find the volume of the soup. The volume of the soup is the area of the cylinder, pi r squared h, which is going to be pi times 12 squared times 18. The answer wants it in terms of pi, which I can do on the calculator. So it ends up to be pi multiplied by 12 squared multiplied by 18 get there is 2592 pi. That's centimeters cubed. Okay. A ladle in the shape of a hemisphere, there's a hemisphere here, is used to serve the soup. Calculate in terms of pi the volume of soup contained in one ladle. So the volume of a sphere, if this was a full sphere, would be 4/3 pi r cubed. I got to half this answer because half it is the volume of a hemisphere. So I have to do volume equals a half 4/3 multiplied by pi multiplied by 6 cubed, and put all that into the calculator. So to put it into the calculator, we're going to get is a half multiplied by 4/3 multiplied by pi multiplied by 6 cubed, and then close the bracket, and what you get there is 144 pi. So V equals 144 pi, once again centimeters cubed. Now we can see that the cylinder is much bigger than the ladle. So the next question then, part 3, how many full ladles of soup does the saucepan contain? Well, basically what we can do here is 2592 divided by 144 pi. It's basically the volume of the saucepan. How do you spell ladles? Okay, so it's 2592 pi divided by 144. Same thing as 2592 pi, and we're going to divide that by 144 pi. We get 18 ladles, 18, okay? So that's handy enough. Now, 2b. Load and chute in a flour mill loads directly into a feeding bin, which is the shape of a circular cone. The curved surface area of the bin. Okay, so the bin is the cone. Okay, so curved surface area of bin is a cone. Okay, so curved surface area of a cone is pi r L, where L is the diagonal part. So L equals 18.2. Okay. Stand height. If the lid for the bin is needed, find the area for the lid. So we have to find out what is the area of this circle. Okay. So our whole point of the question is to find out what is the area of a circle. This circle we don't know the radius of. Okay. And that's where we're going to use pi r L. Pi r L equals 350. Pi multiplied by r multiplied by 18.2. Okay, equals 350. So what we're going to do is we're going to get r on its own. We're going to divide by, it's going to be 350 divided by 18.2 and pi to get r on its own, because they go into division. So 350 divided by 18 pi is 6.19. R equals 6.19 meters. Okay, so the radius of this circle is 6.19 meters. So we give our answer correct to the nearest meter squared. So we need to find out the area of this circle now, and we know it's 6.19 meters. So it's going to be pi times area of the circle. It's going to be pi times 6.19 squared. Then area is going to be pi multiplied by 6.19 squared, and we get 120.37, and it says to the nearest meter, so it's going to be 120 meters squared. Okay, moving on. The given shape consists of a cylinder and a cone. Find the volume of the cylinder in terms of pi. Well, the volume of the cylinder is pi r squared h, and it's going to be pi times 3 squared times the height is 6, 54 pi. Okay, that's part 1. the cone is part 2, is volume of a cone is a third pi r squared h. It's going to be a third multiplied by pi multiplied by r squared. It has the same radius, remember, so it's 3 squared and its h is 4, so that's going to give us 12 pi when we put it all in. Hence find the volume of the shape correct to the nearest centimetre cubed. So the volume of the full shape is your 54 pi and your 12 pi added together, and you're going to get 66 pi. But look, that's not correct to the nearest centimetre cubed, so you put 66 pi into the calculator and what you get is 207 centimetres cubed. So 207 centimetres cubed. Okay, so moving on to the next part. The shape is made by joining a hemisphere of radius r. A shape is made by joining a hemisphere of radius r to a cone of radius r. The height of the cone is 2r. Find an expression in terms of r and pi for the volume of the shape. Well, the volume of the cone is equal to a third pi r squared h. And that's equal to a third pi. The radius is r and the height is 2r. Now, r squared multiplied by 2r is like 2r multiplied by r squared, or 1r squared. 2 by 1 is 2. R by r squared is r3. So it's 2 pi r3 all over 3. Okay, it's the volume of the cone. Now, what is the volume of the hemisphere? The volume of the hemisphere is going to be a half the volume of a full sphere, which is going to be a half 4 over 3. We put that into the calculator. A half multiplied by 4 over 3 gets you 2 over 3. So it's 2 over 3 pi r cubed. Now, we can see that the volume of the hemisphere and the volume of the cone are in fact the same number. So the total answer is going to be 2 pi over 3 squared plus 2 pi over 3 r cubed. You got to add them together. Now ignore the r cubed and just add 2 pi over 3 plus 2 pi over 3. In the same way, if you were adding, let's say, 8 pi x and 5 pi x, you'd ignore the x and you get 13 pi x, because 8 pi plus 5 pi is 13 pi x. So we're going to do the same thing here, just ignoring the r cubes, and what we're going to get is 4 pi over 3 r cubed. And that's our answer. Okay guys, there's questions 1 to 3 on Test Yourself 17 done.